Hello and good day, people. Today I'm going to start off with an introductory um, video on what it is I'm going to be focusing my teaching videos on. So, what I'm going to focus on in the teaching videos is specifically the power, 10 to the power of n equal y log equal n. Okay, so log base 10 equal n, and this is log base 10 of y. So over here is the power, and this is an exponent. This is an exponent. This is an exponent. This is exponential, and this is the power, and the log of y equal n. So that is essentially how this is essentially how the function goes. So if you have 10, 100, 1000, 10,000, and this is y, then n, and f of it is f. Well, you could say the function here is log. The function here will be 1, 2, 3, and 4. So exponent, the power n equal y, log of y is n. So log to base 10 of y equal n. Or in other words, log to base 10, 10 to the power of n equal n. So this is just to get an idea of what is the logarithm doing, you know, and I still researching this. I still researching this to see like what the logarithm is doing. So powers work like this. You have 10 to the power of 1 plus 10 plus 10 dot 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 n equal 10 times. So 10 plus 10 plus 10, right? This is 1, this is 2, and this is 3. This is 3, so 10 plus 10 plus 10 dot 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 n equal 10, 10 plus 10 plus 10 dot 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 n equal 10, and so you could kind of say that it goes like n equal 10. So 10 to the power of 10 to the power of 10, and we could call this m equal 10. So you could say if m equal 10, then n is equal to 10 squared, right? So for cube, 10 cube, we have 10 plus 10 plus 10 10 times, and then and then the sum of 10 times 10 times, going down in a row and in a column. In a row and in a column. So 10 plus 10 equal 10 times. And so for squared we have 10 times 10. And for cube we have 10 times 100. Or we have 10 times 10 squared. We have 10 times 10 squared. And so essentially the power is sigma, the summation, sigma 10 r equal r equal 10 to the power of n minus 1. So this is the number of times 10 is summing. 10 is summing. And this is the power. This is the power in terms of summation. And all numbers could go back to a summation of 1, because 10 is a summation of 1 10 times, and all numbers go through this same thing except for 3. Let me say 3, it will be 3 plus 3 plus 3. So this is 3 to the power of 1. This is 3 to the power of 2. And then 3 to the power of, then 3 cubed will be 3 times 3 squared, which will be 3 times 3 squared is equal to it. And so if in each row you have 10 tens, and then for cube you have 100 tens, you know, in this case you'll have 1 2 3, you'll have 9 threes. It'll be 3 plus 3 plus 3, and 3 plus 3 plus 3, like that. So the length of the column, the length L, is equal to the number itself, x, you know, and the length of the row, actually row, and the length of the column is equal to x. So we could say the width of the column equal x, and the length equal x. The length equal x. Equal x, and each division can be seen as, it can be seen as a form of division, because in 3 here you're dividing 3 by 3. You divided 3 by 3 separate digits. So it's 3 units long, 3 units wide, 3 units long. And you could say that you're dividing each length, you're dividing it by 3 to get 1, and then each width you divide it by 3 to get 1, and you then divide it by 3 to get 1. So this is it here. So I want to touch on one last thing to give a deeper understanding of things that tend to confuse people. So 10 to the power of n equal y, right? Now nth root of y equal 10. Nth root of y equal 10. 10 to the power of n equal y. The nth root of y equal 10. So what is the nth root of y? The nth root of y is 10 to the power of n times 10 to the power of 1 over n. Because roots are fractions as powers. So 10 to the power of 1 over n equal nth nth root is the nth root. So what is a, okay, so a root, okay, so let me finish this part and then we'll go on into the roots. So let me say we have you could say a sum of roots. You could say 10 to the power of a fraction is equal to a sum of roots. You could say it's a sum of roots. So if you had 0.1 is equal to 10 to the power, I think, of 1.25, if I'm not mistaken, or it's something like that. So what we see happening here is when the power is a fraction, so say the power of 10 is a fraction, then is a root, right? But so if 10, then you could say is the nth root of 10, the nth root of 10. Right? And the last thing I want to touch on here, so essentially if 10 to the power of n is a summation of 10 to the power of n minus 1, then the root now, so say the root is 10 to the power of 1 squared, that's the square root of 10, and that's the square root of 10. So 10 to the power of 1/2 is equal to the square root of 10. The square root of 10. And then you summate, so the summation, I forget, but honestly I forget what I was saying about is a summation of roots. What was that again? It was like, for example, when I was going to what was a summation of roots again, boy? A summation of roots was a summation of roots was the logarithm of this is the logarithm of 10 to 1/2 is 0.5, right? So the logarithm of this is 1/2 for the root. So the logarithm is the root. logarithms powers, and you could say that, so a fraction, but let me say it's a decimal, like let me say it's 10 to the power of 0.9, right? 10 to the power of 0.9. Then this is 10 to the power of 0.1 times 10 to the power of 0.1 times 10 to the power of 0.1. So 10 to the power of 10 to the power of 0.1 is the 10th root of 10, which I feel that I think it was 1.25, right? So the logarithm of 0.1, so the power for, right, so this is an interesting topic that I want to talk about. So the 10th root of 10 times 10 to the power of 1/10. The topic here is going to say that the log right, so the logarithm of 1.25 is equal to 0.1, and this is just an example, I'm just hypothesizing. So, or you could say that 10 to the power of 0.1. So what is happening here is, or you could say that 10 to the power of 9 on 10. So you can say that it will be 10 to the power of 0.1 times 10 to the power of 1, 9 times. So 10 to the power of 1 times 10 to the power of 0.1 would be 10 to the power of 0.1 added to 10 to the power of 0.1, a fraction of a decimal number of times. So when I was talking about decimals as powers, we would talk about the root. So it would be the actual number itself will be the 10 so you see what happened here is that it would just multiply, it would say 10 times 1.25. So let me just see what's the actual value for this. It would be like it would be a sense of addition. So number and a fraction 1.25 times 1.25 is just 1.25 added to 0.25 times this added to 0.25 times 1.25, and this will just be 0.25 plus a quarter plus 1.125. So multiplication always breaks down into a summation. And well, yeah, so this is the end of the class. I'll continue on next. I'll do a next video going into more detail into this, and you will get something. You will get something like. You will get something like 1.25. You'll get something like this, right? So essentially what I say in here, it will be a summation. It will be a summation of decimals. You know? So it will be summation of decimals and of roots. So it will be 10, the 10th root of 10 times 10th root of 10 9 times and yeah, so I will look further into this. I will look further into this and that. I will look further into this because if you have a decimal, a fraction, 0.25, and let me say it multiplies by itself, you will get multiplication. So we will have to look at the multiplication, what's going on here. 0.25 times 0.25, you essentially multiply it so you would get 2 times 5, which is 0, and 2, you'll get 50. And you get 5 times 5, and you take 5 and you take it over. 5 times 2, well, quarter, one quarter times 1/4 is 1/16. So you could do it in a multiplication sense. So essentially here I get 0.0, let me see, 571. I get 0.0175. So right, I have the computer now. And I will see it. So let me just check it over here. 0.1 log. Okay, so this was just completely wrong. 10 to the power of minus 1 equal 0.1. 0.1 log, and then um 0.110x, right? But it was still correct. The log of this is equal to 0.1, right? The log of this is equal to 0.1. The log of 1.25, so 10 to the power of 1.25 equal to 0.1, right? And then the next thing I want to check is 0.25 times 0.25 0.0625. 2. You just multiply it 25 by 25. So 25 by 25 is 25 times 25 is like this, so you get 2 times. Well, let me start. Let me do this over. You get 5 times 5, you get 5. 5 times 2 is 10, and you added 1 to 5. And then 2 times 5 is 0. And then 2 times 2 is 5, and 1, 6. No, 2 times 2 and 1, you get 5. So I don't understand how this now. I forget how to multiply. 25 times 25, right? Is equal to 2 times 5, which is 10, I take 0. 2 times 2, which is 5, added to 5 times 5, which you take the, well, anyway, it's probably something like this, 5, 0, and you add it, and you get 5, 2, 6, and you do 4 decimal places. So it's still a summation. The point I'm trying to make with this is it's still a summation, because if you ignore the decimal place, you're still adding, you're still saying 5 plus 5 is 2, and then you still say 2 plus 2 is 4 plus 1 from the remainder. So that is the first lesson. Thank you for watching.